All right, let's suppose you encounter a wave function in the wild. A wave function like this could be the graph of a sine function or maybe a cosine function, and without any context or idea about where it sits in the coordinate plane, we can't really necessarily say whether it's sine or cosine. And in fact, depending on how we construct a function to describe this curve, we could do it in such a way that it ends up being a sine function, or if we make a small adjustment, it could be a cosine function. So overall, waves like this, which are described by sine or cosine, are called sinusoidal. Let me see if I can spell that right. Sinusoidal functions. So when you hear the term sinusoidal functions, it just means sine or cosine because they're both the same sort of graph. It's just a matter of how they're shifted left or right. So whenever you encounter one of these, there's a few key pieces of information about this graph. One is that it bounces up and down, and it has this sort of type of symmetry through the middle. So we can draw a line through the middle, like directly through the middle of this graph right here. And the distance that it goes above that line should be equal to the distance that it goes below that line. So that it keeps on bouncing up to the same maximum height and then coming down to the same minimum height. That distance, well, first of all, this is called the midline. Let's put that down first. That's the midline of the wave. So the distance between the midline and the maximums or minimums, whichever they're the same value, that's called the amplitude of the wave. Amplitude. Okay, and you can measure it there or you can measure it there, as long as you're measuring from the midline to like a local, a local maximum or local minimum. Okay, so we've got midline, we've got amplitude. Then another piece of another measurement you can take on a wave has to do with how long it is. If you measure from one maximum to another maximum, or alternatively, if you measure, for instance, from like an x-intercept where it's going up, you skip over this x-intercept because it's going down, so that's different. Measure over to the next x-intercept where it's going up. Okay, so that would be sort of like from one point on the wave to another identical point on the wave. Whenever you measure that distance, it's the same distance, and that distance is called the period. I mentioned period in the last video, how sine and cosine have a period of 2 pi units, because it takes one full lap around the circle for everything to start repeating. So there you go. So period is the distance between peaks, or alternatively also distance between minimum valleys here. That's also. So there we go. So we've got amplitude, we've got amplitude, we've got midline, we've got period, and then there's one more piece of information. If we happen to know where the x and y axes are, say we know the y-axis is here, right, and the x-axis, maybe it's there. So there's x, there's y. And if we decide that we want to try to describe this curve with, say, a sine function, we know that the sine function starts at 0, right? So like this point right here should be the start of the sine function. And this distance right here, the amount by which it's shifted off from 0, that is called the phase shift. So that's a phase shift for sine. Okay, so that's sine. Because that's where it would start. Cosine, remember the cosine graph, it crosses the y-axis at a point like this, at a maximum point. So that point right there, that would be the start of the cosine graph. So that means this distance, if you measure from 0 over to there, that would be the phase shift for cosine. So the amount of the phase shift, it's basically a horizontal shift. The amount of the phase shift depends on whether you want to describe this with a sine function or a cosine function. Either way, we're going to take one of those, sine or cosine, and do like a transformation, shifting it left and right. And by the way, you can also shift it further. Like if you wanted to shift it all the way over here for sine, you could shift it there. Or for cosine, you could shift it all the way down to here. It's also possible to take into consideration reflecting over an axis, but we're not gonna bother thinking too hard about reflection, because when you reflect something, if you reflect it and shift it, then you can get back to what you started with. So we're going to focus on these four things: where the midline is, how much the amplitude is, how long the period is, and then what amount it's shifted, based on whether we choose sine or cosine. Okay, in the next video, we're going to look at how we can actually calculate all these things with, with a function, and think about it in terms of transformations.